Hi, questions in thermodynamics in this textbook. Problem 2.2. The densities of ice and water at 0 degrees Celsius are 0.9168 and 0.9998 gram per centimeter cube, respectively. If delta H for the fusion process at atmospheric pressure is 6.025 kilojoule per mole, what is delta U? How much work is done on the system? Solution. Recall the definitions. Then we have the volumes for ice and water. The work done is given by this equation. So we get this result. We have this equation. Then we have this result. Problem 2.4. The latent heat of fusion 0 degrees Celsius is 6.025 kilojoule per mole, and the molar heat capacities of water and ice are 75.3 and 37.7 joule per K per mole, respectively. The capacity Cp values can be taken to be independent of temperature. Calculate delta H for the freezing of 1 mole of supercooled water at minus 10 degrees Celsius. Solution. We have this equation. For the process of heating water, we get the heat Q1. In the process of freezing, the heat Q2 is this value. In the process of cooling the ice, the heat is given by this value. Then we find this result. Problem 2.5. A sample of liquid acetone weighing 0.7 gram was burned in a bomb calorimeter for which the heat capacity, including the sample, is 6,937 joule per K. The observed temperature rise was from 25 degrees Celsius to 26.69 degrees Celsius. Calculate the delta U for the combustion of 1 mole of acetone. Calculate the delta H for the combustion of 1 mole of acetone. Solution. The number of moles is this one. Then we find this result. We have this equation. Then we find this result. Problem 2.6. An average man weighs about 70 kilograms and produces about 10,460 kilojoule of heat per day. A. Suppose that a man wears an isolated system and that his heat capacity will 4.18 joule per K per gram. If his temperature were 37 degrees Celsius at a given time, what would be his temperature 24 hours later? B. A man is in fact an open system. The main mechanism for maintaining his temperature constant is evaporation of water. If the enthalpy of vaporization of water at 37 degrees Celsius is 43.4 kilojoule per mole, how much water needs to be evaporated per day to keep the temperature constant? Solution. Case A. The heat capacity is this value. We have this equation. Then we get this result. Case B. Let M prime be the water evaporated to keep his temperature constant. Then the enthalpy change is given by this one. The internal energy change is 0. Then we have this one. Then we get this one. Then we get this result. Thanks for watching. Bye.